This narrated set of notes serves as an introduction and overview to the highlights of Week 8 topics, focusing on Sessions 1 and 2, using advanced logical functions. Here are the major themes for Module 8, Sessions 1 and 2. Conditional logic functions, lookup functions, and if-error functions. For a few of you with a programming background, you will recognize that Excel has several logical functions to support making decisions. This is much like a programming language. Module 8 consists of 3 sessions. 2 are covered in these notes, and Session 3 is covered separately. Here are the learning objectives for these set of notes. We will be discussing the if function, the use of and or logical functions, as well as structured references and formulas that you have seen before in Module 5. Session 8.2 covers nested if functions, the use of lookup functions for vertical tables and horizontal tables, as well as the if-error function. Carefully review the Session 8.1 visual overview before starting the module exercises. Logical functions result in yes or no, true or false type of answers. Some Module 8 preliminaries. In order to effectively communicate a table's function, keep the following guidelines in mind when creating fields in an Excel table. Create fields that require the least maintenance. For example, hire date and birth date require no maintenance once the data has been entered. Fields such as age and years of service should be calculated fields because these values do change with time. We can recalculate these based on known or fixed fields such as birth date and or hire date. 2. Store the smallest unit of data possible in a field. For example, it is better to use 3 separate fields for city, state, and zip code rather than one field. The reason is this allows you flexibility when filtering the data. Perhaps you just want to search on a zip code, or alternatively on a city. If these are in 3 separate fields, you will have the flexibility to do so. 3. Apply a text format to fields with numerical text data. For example, we live in South Jersey, most of us anyway, and we use zip codes that begin with the digit 0. If we have our zip codes with a numeric format, we will lose that leading 0, which will be a 4-digit incorrect zip code. So when we're using numbers as text, we should not be formatting it as numbers, but instead use a specific text format that will allow us to not lose that digit 0 at the front end of our zip codes. Another example of this is a Social Security number. Again, we never do arithmetic with this type of data. Even though we call it a number, we never multiply, divide, subtract, or multiply. And so, if that's the kind of data you are storing, it's likely best stored as text and not as a number type of format. These guidelines will help you be more productive and more easily be able to analyze results from the fields you create. Recall the calculated columns work only in Excel tables. Inserting calculated columns in an Excel table is a great idea. It allows us to enter a formula in one cell of the column, and it will automatically copy the formula to all the cells in that column. We could modify the formula in just one column, and it will change them in all of the entries. Or if we need to edit just one cell and do that differently, we can make that individual cell different from all the others. However, we can't do this with range of data. In that case, you need to copy and paste the formulas or use the autofill in order to do so. Working with logical functions. We use the term conditions when we want to test values in a comparison way, using the relational operators less than or equal to, not equal to, greater than, or greater than or equal to. These are the 6 relational operators available to us for comparing data. Note that the not equal to is the 2 arrows. The result of these comparisons will always be true or false. We are making yes or no decisions. We do this by checking the results of an if function. Logical functions and or allow us to combine multiple conditions to determine whether an overall set of conditions result in true or false. We will examine all 3 of these. Using the if function. On the right-hand side, we have a pictorial of making a decision. Inside the diamond, we will list the condition that we are evaluating. Typically, you will see a value on the left of one of those relational operators compared to a value on the right. From this, we will get a yes or no, true or false answer. This is what's called the logical test. So the condition we are evaluating corresponds to the logical test in the if statement. If the result is true, we perform the action described in the statement under the true arrow. If the answer is false, we perform the actions described in the red statement under the false path. There will always be a yes or no, true or false result from a relational question. Here's a sample if that just has one condition to consider. In the birthday month column of the table, we decide whether or not the employee's birthday matches the current month. The current month is stored as integer 4 in cell E16 in the data tables worksheet. Let's look at that logical test. The month of F2 refers to the table we see here, employee's birth date. We're comparing that to the value found in the data tables worksheet, cell E16, which currently has the value of 4 for the month of April. In cell birthday month, in that column, we will put a yes corresponding to this row if the birthday month of this employee is April. If the birthday month is not April, we will just fill it with a blank. So that will be our value if false. We have 2 quotes with nothing in between them, representing that this is null or empty. Here is the result from running this if check. We see that the first employee did in fact have a birthday month of April, then the next several did not, and then we see one more with a birthday month of April. Whether or not you have a programming background, I highly recommend formulating your logical functions using the available dialog boxes as a guide. Although when we are following the book's instructions, it is quicker to just type in the logical condition and expressions, it is hard to correctly format them in long expressions. So my strong advice to you is to get used to using the dialog box for forming these expressions part by part. Using the AND function logically tests 2 or more conditions, up to 255 different conditions, to determine whether all of the conditions are true. Again, the return will only be true or false. For a value true, all the logical conditions have to have evaluated to true. If any one of those conditions were false, then the overall outcome of the AND will be false. Here is the syntax for the AND logical function. We start with the keyword AND then in parentheses we list the conditions we're checking. Note that we only have to check one. Anything inside those square brackets is optional. So after listing one condition, any remaining conditions we need to check are optional, and we could allow for up to 255. So here's an example. The law says men must register with Selective Service within 30 days of their 18th birthday. We could write a logical AND function for this that would check the gender as male and the age greater than or equal to 18. Here's our check. Gender equal to capital M for male. That's logical condition 1. And age greater than or equal to 18 as logical condition check 2. If both are true, well, Uncle Sam wants you. Alternatively, we have the option of using the OR logical function. Let's compare the OR to the AND. The OR results in true if any of the conditions are true. If any one of the conditions is not true, the result will be false. Here is the syntax for the logical OR. Again, we see one required condition, and then we can have as many as we need, up to 255 different conditions that could be checked. Here is an example that would turn on the air conditioning if the temperature were greater than or equal to 75 or the humidity was greater than 55. If either one of those is true, the air conditioning should be turned on. We should be using structured references when we create formulas in our Excel table. It makes them much more readable. Here is an example of that, using an OR to check the store value set to either Bonham or Graham. So store is the name of the column in our table, and if the entry for the row is Bonham or Graham, then the result of our OR will be true. We can replace specific cells or range of addresses with these structured references to make our program's logic much more understandable. Session 8.2 reviews nested ifs and lookup tables. You want to review the visual overview and then familiarize yourself with the content stored in the data tables and product data worksheets. Take your time with Session 8.2. Now that we are considering more complex logic functions, it is easy to become confused. You really need to understand the underlying logic that you are expecting Excel to accomplish so that you can be sure it is providing you with the correct results. Note that you can examine formulas by using the toggle Control plus tilde, which is the little squiggly, and this key is usually found under the Escape key on most PC keyboards. Nested ifs allow for making multiple alternative decisions. Recall that with the if, we had two possible outcomes. When we need multiple choices, then we need to place one if function inside another if function's false path. It is possible to nest more than one if function. You can nest as many as you need. For 3 outcomes, we would need 2 if functions. For 4 possible outcomes, we would need 3 if functions. Here is an example from the module. Let's start by examining the pictured flowchart. First thing to notice, there are 2 diamond shapes, one for each one of the conditions we are checking. Given 2 diamond shapes, or 2 if statements, we see that we could have 3 possible outcomes. And so we see 3 rectangular boxes representing the result from these nested ifs. They are color-coded to match the if statement underneath it. Let's drill down. If the years of service were greater than or equal to 10, the truth of that, or truthiness, would allow us to set the employee's bonus to 500. So the first part of the if is checking the years of service greater than 10 or equal to 10. If that is true, the bonus we will be giving will be 500. But if that's not true, we are going to then check, was the years of service greater than or equal to 5? Now, if that is true, we follow the true path and assign a bonus value of 250. But if that's not true, then we follow the false path and we will be assigning a bonus value of 100. If we needed to add another possible bonus outcome, perhaps we're not giving any bonus to employees who have not worked at least a year. In that case, off the false path of our blue, years of service greater than or equal to 5, where we have bonus equal to 100, we would need to replace that with another diamond shape, checking for years of service greater than or equal to 1. And if that were not true, the bonus would be 0. So we see here that with one if statement, we have 2 possible outcomes. If we need more than 2 possible outcomes, we add additional if statements nested inside the false path of the original if. Drilling down again, looking at the if statement, years of service is greater than or equal to 10 is true, then 500 will be the bonus. But if the years of service were not greater than or equal to 10, then we will again check years of service greater than or equal to 5. If that is true, give a $250 bonus. But if that is not the case, our employee will receive a $100 bonus. Using lookup functions. Lookup functions allow you to use tables of data to find values in that table and insert them in some other worksheet location. An example of a lookup table would be a phone book. You could also think of a lookup table like a dictionary, where you find the word in the dictionary, and it's usually placed in some order, right? In a dictionary, it'll be alphabetical. And once you find the key word you're looking for, you then can read its corresponding definition. Both the VLOOKUP for vertical and HLOOKUP for horizontal are used to return a value from the lookup table. When we use VLOOKUP, we are searching through the first column of a table to find a match. When we are using HLOOKUP, we are searching for a match in the first row of the lookup table. These tables can be constructed as either exact match or approximate match. Exact match lookup occurs when the lookup value must exactly match one of the values in the first column or row of the lookup table. An approximate match lookup occurs when the lookup value is found within a range of numbers in the first column or row of the lookup table. Here is the syntax for a VLOOKUP. The first value inside the parentheses is the actual lookup value we are trying to match with. The next input is the name of the table array. The third input is the column that we should pull the value from if we find the match. And the fourth optional input we see here for range lookup will be left blank or with a value of false for an exact match. The range lookup will only have a value supplied when we are looking for a range match. So for approximate matches, there will be a fourth input for the range lookup. Here is a sample VLOOKUP for vertical. We're looking at cell B2's value. That's containing the matching value that we're searching for in the product suppliers table. Now remember, we don't need to supply the column number that we're checking because it will always be column number 1 for a VLOOKUP or row number 1 for an HLOOKUP. So we will be searching down the first column of the product suppliers table for a match to the cell value that resides in B2. The third input here, number 2, tells us that we will be pulling out the value in the second column as the result if we find a match. False indicates that this is an exact match. So the contents of cell B2 needs to exactly match a value in the product suppliers table first column. When we're working with an approximate match, we'll be returning a value based on a range of values that match in the first column of the table. This is useful for when we're trying to find quantity discounts, shipping charges, income tax rates, which would be a range of values based on criteria that would be stored in the first column of the lookup table. Here is a pictorial of using the vertical lookup table of product suppliers. Again, note, it will always be the first column of the table that we'll be looking in to find the match. So VLOOKUP B2 had a value of floral crafting. We see that we find a match for that in the product supplier, column 1, product category, and then we pull the supplier value, which is column 2, as the result from our lookup. The false indicates here that it must be an exact match. Floral crafting exactly matches the product category floral crafting. We pull the value silk flowers from column 2. HLOOKUP, we're looking across a row. The formatting of the function is the same. We identify the lookup value, the name of our table array. In this case, we are supplying the row index number. And then, as an alternative, if we have an approximate match, we will also supply range lookup. Otherwise, that last input, the fourth one, will be false to indicate it should be an exact match. The HLOOKUP searches horizontally across the top row of the table and retrieves the value in the row you specify. The major difference between HLOOKUP and VLOOKUP is just the orientation of the table. Here is a sample from Module 8 that uses a horizontal lookup table orientation. We could look across the first row for the floral crafting product category and then select the specialty store Bowie as the result. Our last topic of discussion is the if-error function. You will use the if-error function to find and handle formula errors. Looking at this table, we see that when we did the VLOOKUP, we could not find a match for all in the supplier name or specialty store lookup tables. The VLOOKUP was looking for a match for the product category from the suppliers table, and there was no entry for all. So the result for supplier name and specialty, we're getting the pound N/A. Error values indicate that an element in the formula or cell referenced in the formula is preventing Excel from returning a calculated value. You can review these from Module 3, Figure 315 on page 152. The if error will allow us to display a more descriptive message that helps the user fix the problem. We can determine if a cell contains an error value and then display the message you choose rather than the default error value. In the lab, you will use if error to provide an alternative message of various because they can find what they're looking for in various locations. You will accomplish this by nesting the VLOOKUP expression we see here inside the if error as the expression. The value if error part will be tagged as quote various unquote. So if there's a matching result, that's not a problem. That's what will be shown in the columns. But if there's a problem, the value if error will be displayed as various inside these fields. This is the end of Module 8, Part 1, covering Sessions 1 and 2. If you have any questions or wish to discuss any of these features, please post to the class forum for Week 8.